Okay, so today we are talking about graphing logarithmic functions and applications. You guys are going to be able to graph logarithmic functions, just like how we did exponential, as well as be able to complete different types of application problems, which are your real world situations with exponential functions. Not so many real world applications involve logarithmic functions. However, we might need to use a log here and there to solve an exponential real world problem. Okay, so to start off with graphing logarithmic functions. So when you're graphing logarithmic functions, okay, this is the general makeup of a logarithmic function. You guys have this all in this one sheet, okay? It's like a reference guide, all right? F of x equals log base b of x minus h plus k. That h and that k are the same h and k from the exponential, from the quadratic in the past, okay? The h is going to be your horizontal shift where you moved it left and right. The k is going to be your vertical shift moving up and down. Okay, of course you have to have your b, that's your base. That's going to help you when it comes to actually plotting the different points for a logarithmic function. Okay, so for example, you have log base 4 of x plus 2 minus 1. That means this graph got shifted to the left and also down 1. Now, one thing that this function is missing is what? What transformation is not present on this page? The shrink of the or the stretch. Where would that go, you think? It it goes before the log. Yes. So what I need you to add into the sheet is that there technically is an a in front. That a does represent the horizontal shift and the vertical, not the horizontal shift. I'm sorry. The vertical and horizontal stretch of these logarithmic functions. So the same rules apply. Okay? All right. So if anything, 3 basic steps when you're graphing a logarithmic equation. Okay? 1, make your table. Okay? Your parent function is basically always in this format. 1, 0 is always a point on your most basic function, the one that doesn't have any of the transformations, and then b1. B is the same b that corresponds to the base. Okay? So as you can see, this table right here of a 1, 0, 4, 1, those are 2 points that are on your logarithmic function. Okay? But when you have your horizontal shifts, your vertical shifts, and your stretches, that's when those original points are going to change. So if I shift it to the left 2, that means I'm subtracting 2 from my x values. That's where the negative 1, the 2 came from. Okay? The minus 1, the down 1, you subtract 1 from your y's. That's where the negative 1 and the 0 came from. Does everybody understand that? Okay, so you get your most basic logarithmic function, apply your transformations, and then you actually plot and sketch. Okay? All logarithmic functions are going to have a vertical asymptote, just like how an exponential function would have a horizontal asymptote. Okay? Questions on graphing logarithmic equations? 3 steps. Table, shift, plot. Okay? Few details. Few things that you do need to be aware of with your logarithmic functions, of course, domain and range, x-intercepts, and your vertical asymptote. Your most basic logarithmic function, okay? Looking at this graph, this is your most basic. What would be the domain of this logarithmic function? It's going to be x is greater than 0 because every logarithmic function has a what? Has a vertical asymptote. And if you see this right here, this curve is getting very, very close to my y-axis, but it's never going to cross or touch. So domain is all numbers that are greater than 0 for your most basic. So if you write that in set notation, it will look like so. No line underneath. I did put Y. Sorry, I looked at range and then I wrote Y. My mistake. Good catch, though. How would I write that in interval notation? Very good. Okay. So this is your most basic one. That's log base 4 of x, log base 3 of x, log base 18 of x. Every single one, that is its domain. So what transformation is going to change my domain? Say again? Who said it? It is going to be h, because h does what? It's a horizontal shift, shifts it left and right, okay? Very good. What about the range? What's going to be the range of this logarithmic function? All real numbers. So that's negative infinity to infinity, or the set of y values, because this is range. It's the element of all real numbers. Okay? Yes? It is greater than 0 because there's an asymptote at 0. All logarithmic functions are going to have an asymptote there, and this is a logarithmic function, not like rational where there's 2 branches. It's only going to have that one that shoots off in one direction. Other questions? Okay. Your x-intercept is what? 1, 0. Again, this is for your most basic, so if it shifts left and right, your x-intercept is going to change. And then the vertical asymptote is what? X equals 0. And so, of course, if you shift it left or right, that is also going to change as well. Okay? But again, these are for your most basic logarithmic functions minus any transformation. All right? So you guys are good? All right. Will you be expected to know domains and ranges? Of course. I wouldn't just do it for my health. All right? Let's look at some examples. You go into that red lava color foldable. Okay? Here's where all of our examples are. So we have a log base 3 of x minus 2. First, let's talk about the transformations. Taylor, what happened to the original logarithmic base 3 of x graph? What happened to it? It's going to go to the right 2. Remember, when on the inside, it's always the opposite. So even though it says x minus 2, that means it moves to the right 2. Okay? So we have to take our most basic table and add 2 to which coordinate, the x or the y? The x, okay? What is the most basic table for log base 3 of x? 3, 1, okay? It's always b1. So if b is 3, then it's 3. So then if I am subtracting, moving to the right 2, that means I'm adding 2 to the x. So my new table is going to be 3, 0, and 5, 1. Because you add 2 to each of your x values. Because we're moving to the right 2. Okay? So then we'll plot those. That's going to be 3, 0. Then it's going to be 5, 1. And remember, when we shift, everything on that graph shifts, which means that vertical asymptote that was originally at x equals 0 is now where? X equals 2. So we'll have a vertical asymptote at x equals 2 that we need to make sure that we draw in because we can neither cross nor touch that line. And so we trace along, go through those 2 points, trying to make the smoothest curve possible. That wasn't my best. Hopefully I get better by the time we hit number 4. Questions? Yes. Because again, that's for any basic logarithmic function. So b can be any number that's greater than 1. So like I said, log base 3 of x, log base 18 of x, it's always x equals 0. It's when you start shifting is when it changes. Okay? Questions? Horizontal shifts affect your x's. Vertical shifts affect your what? Y's. A affects your what? Is a stretch or a shrink, which means it affects your what? Your x's or your y's? It affects your y's. In what sense? Am I going to add that number, subtract that number, multiply that number? So a horizontal shift, just like when we were doing quadratics, just like when we were doing exponentials, you're going to either add or subtract that h value. If there was a k, if there was a vertical shift, you're going to add or subtract that value to your y's. But if there's an a, you're going to what? You're going to multiply your, which coordinate? Your y's. I'm having you guys repeat this multiple times because I noticed that a lot of you guys didn't even write down the additional details about a logarithmic function. So I need to make sure that you guys are understanding. Okay? These are the same effects. These same effects are applied to exponentials. They're applied to quadratics. Okay? It hasn't changed. Let's look at this one. What is happening to the most basic logarithmic function, Garner? No, the base is 3 here. What's happening to log base 3 of x? What's happening to it? No one. Make sure you look at number 2. Which way? Left, right, up, down? No, not right. It's going to be up. What's the difference between this one and the last one? There's no parentheses. So that means that this represents the k, which means this graph is going to go up 3 units, which means I'm going to add 3 to which coordinate? My y's. What's my most basic table for log base 3 of x? 3, 1. So then that means this graph of log base 3 of x plus 3 is going to be 1, 3, 3, 4. So 1, 3, 3, 4. Where's my vertical asymptote? As an equation? X equals 0. Because that's how it is based off of the most basic logarithmic function. Remember, the only thing that's going to move a vertical asymptote is a horizontal shift. Because we moved it to the right too, so that meant that everything moved too. But because this didn't shift left or right, it just moved up, it still stays at 0. And so then we go along our vertical asymptote, we go through our points, and there's our logarithmic function. Questions? Anything not making sense? Okay? I want you to try number 3. I want you to try number 3. I would love for you to do 4 as well, but we'll baby step it. Okay? So you're doing 3 and 4. Doing 3 and 4. Okay, so let's look at number 3. Okay? Describe what has happened to the graph, Amy. I think I missed it. You said right? Left? Okay. So left 1 and then what? And then up 4. Okay, so my most basic log base 3 graph is changing. So if I'm moving left 1, that means I'm doing what, AJ? Adding. Subtracting 1 to the x and what to the y? Adding 4. Okay, so my most basic table is going to be what? Anyone? So when I do the different transformations, these are the points that I'm plotting for log base 3 of x plus 1 plus 4. I am subtracting 1 from my x's, so that becomes, and then 2. And then for my y's, I'm adding 4, so that becomes, so those are what I plot. Is my vertical asymptote changing? Where is it now? X equals -1, so I make sure I draw that in, and I trace along, oops, I touched it. I trace along, okay? What about for the last one? What about for the last one? Elise, how's my graph changing? It would be narrower, yes. So that means I'm going to do what to my what coordinate, Joanne? I'm multiplying 2 to all my y values. So again, one last time, my most basic table of 1, 0, 3, 1 is going to be changed, and it's going to be what? 3, 2. Now, where's my vertical asymptote? It's still at 0. Very good. Remember, only horizontal shifts change. Missed both those points. Change my vertical asymptote. Okay? And because I have a strong feeling that this is probably going to happen, why did we use 1, 0, 3, 1 as our base table? Yes. Because the log base was 3 for every single one of these problems, which means that in your homework, when I use 2, 4, and 5, you're going to have to change what part of this base table? The second x. This right here is whatever the base is. Because I would hate for you to do those problems on your homework using a base of 3 with only one of those as a base of 3. Okay? So be aware of that. Okay? Questions on graphing logarithmic functions? Yes. Only the y values by 2. The x's would have been multiplied if there was a number right beside the x being multiplied. But we're not going to deal with those. Leave that for your next class. Other questions? Okay.